Okay, so today we're beginning a new unit. This is Unit 9, and Unit 9 is going to be all about conic sections. And so the first conic section that we take a look at here is circles. And so let's start by having a general discussion on conics. So what is a conic section? All right, so it's an intersection of a plane and kind of a double-naped cone, which is a cone where you've got two cones and they're connected at that vertex. So by taking a plane and intersecting that double cone at various angles, it produces different types of conic sections. So like, for example, if you come through with the plane and slice through the cone horizontally, then the place where the plane touches the cone produces a circle, right? If you take the plane and you tilt it to where it's not horizontal anymore, then the intersection becomes an ellipse. If you take it and slice it this way, where it comes up the top or the bottom, then you've got a parabola, right? And if you take it where it comes through and it slices both cones, then the figure you end up with where it intersects is a hyperbola. And so in this unit, we'll discuss each one of those different types of conic sections, beginning with this section focusing on circles. All right, so just another fact here: when a plane does not pass through the vertex, the resulting figure is a degenerate conic. All right. Now, the general form for the equations of conic sections would be this, right? Where you've got your coefficient a, b, c, d, e, f, and then descending order of kind of each one of the variables. So x squared, xy, y squared, x, y, and then the one without any variable at all set equal to 0. All right. Now, in order for this equation to produce a conic, a, b, and c cannot all be 0. All right. So if all three of them are 0, then you don't produce a conic anymore. And so what we'll do is, once we cover a section on each one of these specific types, then we'll go back and cover this equation a little bit more in depth. All right? Let me see. What else we got here? Okay, we come to now the formal definition of a circle. A circle is a set of all points in a plane that are equal distance from a fixed point, called the center of the circle. Okay, so the distance, radius between the center and any point, r between the center and any point, is the radius. So to produce a circle, you pick the center, and then you come up with a fixed distance. That fixed distance is the radius. So if I say my fixed distance is 5, so anywhere I go 5 from that point, that center, that would be a point on the circle. And all the set of all the points that are exactly, say, 5 centimeters away would produce the circle. Okay? Now, here's the standard form for the equation of a circle. So x minus h squared plus y minus k squared equals to r squared. H and k is the center of the circle, right? And r is the radius of the circle, okay? And of course, if your center is 0, 0, this would be the form of your equation, because those would zero out, okay? Now, what are the types of problems that we're going to be looking at here? Okay, so here's the first example. It says the point 1, 4 is on a circle whose center is -2, -3. Write the standard form of the equation of the circle. Now, to write the equation of the circle, you need two things. You need the center and you need the radius. So like to write the equation of the line y equals mx plus b, you need the slope and the y-intercept. You need the m and the b. Well, to write the equation of a circle, you need the center and you need the radius. They've given me the center, right? So what that means is I need to now find the radius. How can I do it? Well, if this is the center and this is a point on the circle, the radius would be the distance between these 2 points. So to find the radius, I'm just going to use the distance formula. So it'll be square root of. And the easiest way to do it is to see what the difference is from 1 to -2. 1 to -2 is down by 3. Even though it's down, I don't even have to put negative, because negative times negative is a positive. It's going to square itself out in the very next step. So all I need to do is put the change. I don't even have to worry about the sign. So from 1 to -2 is a change of 3, plus 4 to -3 is a change of 7. So that'll be squared. right? And so from there we can go square root of 3 squared is 9, 7 squared is 49. And so I can add those together and get the square root of 58. Okay, so my radius is the square root of 58. Now I have everything I need to write the equation of the line. I have the center and I have the radius. So the center goes here, the radius goes here. And so when we go to write it in, the equation of the circle now becomes x. And so here's my center. Minus 2 will change to plus 2. All right. Why did I do that? Because look at the formula. The formula here is minus. So minus negative 2 is the same thing as plus 2. So in essence, that negative right there is just going to change the sign of whatever the value is. So minus 2 goes in as plus 2. Don't forget your squared. Plus. Now we'll open y. Minus 3 changes to plus 3. Close. Squared. And the square root of 58 squared is just 58. All right. So there you go. That is the equation for this circle. Okay. Let's practice another one now. We want to know what's the equation of the circle with the center negative 2, 7, containing the point negative 2, 3. Once again, we have the center. We need to find the radius, which can be done with the distance formula. So from negative 2 to negative 2, that's a change of 0. From 7 to 3, that's a change of 4. And so that becomes the square root of 16, which is 4. So my radius is 4. So now I'm ready to write the equation of the circle. So it'll be x. Remember, make sure you're using your center and not the other point when you go to make the equation. So minus 2 changes to plus 2 squared plus y. Plus 7 changes to minus 7. So make sure you change the sign as you drop these in. And then 4 squared is 16. And then there is the equation of the circle. All right. So again, use the points to find the radius, the distance formula. Then from there, plug your center in, change the signs, square that, goes here, you're done. Now there's a different type of problem that we can be looking at. It says now identify the center and the radius. So last time they're giving us points and asking us to write the equation. Now they're giving us an equation and say what's the center and the radius. Well, the first thing I need to do is get this into a form where I can read off the center and the radius. Right now, this equation is in this form. All right, I need to turn it into this form so I can read off the center and the radius. So the question becomes, well, Coach, how do we do that? Okay, so in order to turn it from this form to this form, we can use a method called completing the square. So what I can do here is I can go x squared minus 6x, and I can complete the square for the x portion of it. Okay, so completing the square was a method that was used in Algebra 2, so some of you may remember it. What you do is you divide this value, the coefficient of the x, by 2, okay? Then take that and square it, and then add that on to the end of the polynomial. So right now, if I take this negative 6 and divide it by 2, that's negative 3. But negative 3 squared is plus 9. So I'm going to add 9 here. Okay, and you'll see the result of this in a minute. But that's the procedure. Half this number and then square it and add it to the end. I want to do the same thing with the y's here. So it'll be plus y squared minus 2y. All right, so negative 2 divided by 2 is negative 1. And negative 1 squared is 1. So I'm going to add 1 to the end of that. So again, it's always whatever the coefficient of the x or the y, the single variable, the single powered variable is, half it and then square it. So that's called completing the square. Now this 6, I'm going to go ahead and move over to the other side and make it minus 6. Now, I'm not done with this step yet because I have changed this equation. I added 9 here and I added 1 here. So to keep it equal on the other side, I need to add 9 and add 1. Does that make sense? All right. Or you could just say plus 10 if you wanted to go ahead and put them together. but I added 10 to this side of the equation. I need to make sure I add 10 to the other side or it will not be equal anymore. Okay? So be careful with that. So that's the complete first step. All right? So we have completed the square for the x terms and the y terms. How does this help me? Okay? It helps me like this because now I can factor this part. Look at this. So this will be x. And so my signs here, negative and negative would make a positive because I want my middle one to be negative, right? And now what I'm going to do here at this point is I'm going to say, okay, so what's the numbers that can multiply together to give me 9? Negative 3 times negative 3. All right, but in the middle, negative 3x minus 3x is 6. So instead of writing it out as two sets of parentheses, I'm just going to put the 3 there, close it, and squared. All right? Because it's x minus 3 times x minus 3, which is x minus 3 squared. Okay, so that's the purpose of completing the square to see what number should go here, right? And then that's plus, and now let's do the same thing with the y's. So I've got y. Let's see here, what will we do? Since that number is negative, it's going to be minus, and it's going to be 1 times 1 is 1. And look in the middle, negative 1y minus 1y is negative 2y, so we'll square that. And then that's going to be equal to 4 on the other side. Okay? Now, we can see how this helped me because look at this equation now. I have turned it from this form back to this form, and now I can answer the question. Identify the center. The center is 3, 1. Identify the radius. The radius is the square root of this, which is 2. All right? Make sense? Okay, because remember, this number is r squared. So if 4 is r squared, then r is 4. All right? So again, we completed the square to turn it from the standard form into this form. And then once we have it in this form, we can just read off the center and the radius. Make sense? All right, so let's see. What else we got? So again, we have the same type of problem. We want to identify the center and the radius. So our first step is going to be the same. We want to complete the square for the x terms and the y terms. So we'll go x squared minus 14x. Okay, half of negative 14 is negative 7. Negative 7 squared is plus 49 plus y squared plus 8y. All right. And let's see, half of 8 is 4. 4 squared is plus 16. All right. Equals, I need to go ahead and move the 40 over. It'll change to minus 40. I adjusted the left side. Let's adjust the right side. Plus 49. I added 49, and I also added 16. All right. So now we're back equal again. And we can now do this. 7 times 7, so that'd be minus 7 squared, negative 14 in the middle, plus y, plus this time in the middle, plus 4. 4 times 4 is 16. 4 plus 4 is 8. Equals, that'd be 9 plus 16. I'm going to get 25 here. And now we're ready to write the answer. The center is 7, negative 4. Change the sign. And the radius is square root of 25, which is 5. And that is it.